So what does this reaction look like for the single reaction with hydrobromic acid and iron? It's dissolving the iron? I don't know if dissolving is the right word, but it definitely goes into the aqueous state, right? Yeah, maybe dissolving is okay. Hydrobromic acid and the HBr state is what? Aqueous. What are the options for gases? Sorry, what are the options for acids? States. Gas or aqueous. But why did we say it's probably not a gas?
It'd be difficult to handle a gas.
Yeah, how are we gonna mess around with that? I'm probably gonna want it to be in a liquid. Okay, so then on the other side of the equation, what do I get? What'd you guys put, 2 or 3?
I didn't know.
That's really the important thing is you don't know, except you could, if you looked on the table and looked at the oxidation states on your periodic table, which one's bold? 3. So that's the most common oxidation state. Under normal conditions, under normal atmospheric conditions, you're gonna have 3 formed. So this will be 3. And aqueous, are we okay with that? How come it's aqueous? Do you have a solubility rule for iron? No. Do you have a solubility rule for bromine?
Yes.
Yes.
Bromides are soluble.
And bromides are soluble. All right, so how do I know that there's water present to actually dissolve this iron 3 bromide? Because the acid was aqueous, and aqueous means mostly water. Okay, and then what's the other product?
Hydrogen gas,
Yeah.
H2.
Just straight H2 gas. Alrighty. So if I start with 125 and 275, will be left in the container when I'm finished. Okay, so if I have 125 grams of iron, and then for every 1 mole of iron, I've got 55.847 grams of iron. Probably need to balance this, yeah. So a 2, no, that's not gonna work. 3, odd number, even number issue. If I put a 2 there, and down, okay. Let me switch colors. If I put a 2 there, then I can balance out my bromines by putting a 6 here. And then I can put a 3 here to balance out my hydrogens, and I can put a 2 there to balance out my irons. And then make sure you go through to see if you can divide through, and we can't divide through, so we're fine. So there's our balancing. So back to the problem. I've got 2 moles of Fe, and which product do you want to check? Doesn't really matter which one, but I'd probably pick hydrogen just because it's easier to calculate its mass. Doesn't really matter which one since I'm gonna need to know everybody. So then I'll have 3 moles of H2, and then for every 1 mole of H2, it's 2.0. What is it? All right, I don't have my phone, so what
It's
is it?
2.0159.
Yeah, that's it. Mass H2. Where did this 2 and 3 come from in this mole to mole ratio? From the balanced chemical equation, right? All right. So somebody got an answer for me here? 125 divided by 55, 3, 2, and 2.
6.77.
6.77? Okay. So we're gonna have to do the exact same thing, except this time we're gonna have to start off with the hydrobromic acid, right? So 275 grams of HBr. Then for every 1 mole HBr, grams of HBr, so bromine 179, so 80, I don't know, 0.9. 1, maybe 2, something or other. Then for every 6 moles of HBr, it'll be 3 moles of H2, 1 mole H2, 2.0159 grams H2, and then grams of H2. Let's see. Three, 2.88? Really?
About 3.425.
That sounds better. Okay, so which reactant is the limiting reactant? The HBr. The moment that I've made 3.4 grams of hydrogen gas, what happens?
You're all out of hydrobromic acid.
I'm all out of HBr. It's gone. So it doesn't matter that I could make a lot more with the iron. I just don't have any. So what are the substances that are going to be left in the container when this is finished? Iron,
HBr and.
no HBr.
Or, yeah, HBr.
Iron 3 bromide, iron 3 bromide, and hydrogen gas. That'll be the only thing because the HBr is gone. Okay, so I know there's this much hydrogen, so that answers that portion of the question. I know that there's 0 grams of Fe. Am I gonna have to do another calculation for this, or can we just math it out, subtract it out? Looks like I'm gonna need to do one more. Okay. So we'll do 275 grams of HBr and 80.912 grams HBr. 1 mole HBr. And then 6 moles HBr. And now we'll swap over to iron 3 bromide. How many grams of FeBr3? So $79.09 904 times 3 plus 55.847 295.58.6. Okay. And grams of FeBr3. So what's that going to be? So that'll be about 200 and something. Okay.
87.
Let's go 335. This will be 3.3 since we have 3 sig figs. Okay, so I know I've got grams of iron or hydrogen 3.43, and my iron 3 bromine is 335 grams. And so, oops, not 0 iron, 0 grams of Yikes. 0 grams of HBr. So how many grams of iron do I have? Well, I started with 400 total grams, and so 335 of it is that, and 3 of it is that, so 400 minus 338.43? 338, so that'd be 61.
61.57.
Okay. That's what's left in the container. Do we have any questions about that one?
How do you know the second H2 is what's left over as opposed to the first H2?
The moment that I've made 3.43 grams of H2, what happens?
You ran out of
HBr. It's gone, right? So could I make 3.44 grams of it?
Yeah.
No.
Oh, sorry, I thought it was 0.45. Yeah.
I can't make that, right? So I couldn't, definitely not make 6.77, because once I've hit that 3.43, I'm out of HBr.
Okay.
So whichever number is the smallest, it's sort of that you're making apple pies and you run out of apples, right? You can only make so many pies as you have apples, kind of deal. Same question for this one. What's the first thing we should do here?
Balance.
Balance this out. If I put a 10 here, 16 here, and 8 here, does that work? What about states? What would you put down?
Aqueous.
Aqueous for the first one?
What is it?
It's a hydrocarbon. What other hydrocarbons do you guys know? No, there's oxygen in that. Propane, gasoline. Is gasoline a gas? The number is around 4. If there are 4 or more carbons in it, it's probably a liquid or a solid. So what do you want to say here? How many carbons are in gasoline?
8.
It's octane, right? There's 8, and so that's a liquid. And how many do I have here? 10. So it's probably a liquid. How about the chlorine?
When is it a gas? When it's 4 carbons?
Propane is 3. State for the carbon? Carbon state,
Solid.
solid, and this HCl? Ha, tricked you.
Gas.
Do you see any water?
No.
So it's
Must be gas.
So it's a gas in this case. It was just made, right? It's not a reactant. It's not something I mixed together. This stuff was just made, and there isn't any water present. So what state would it be? Gas. What?
This is just confusing. So if it's not on the reactant side, then it's a gas.
Most likely because you just made the stuff.
Okay.
And the acids are most likely going to be gases unless you put them into a solution and made them aqueous. So if I want to make hydrochloric acid, I don't take a liquid hydrochloric acid and mix it with water. There is no liquid hydrochloric acid at room temperature. It's a gas. So can you see why that's a pain in the butt to work with in the lab? I have to use it in the gaseous form if I want it to be 100%. So I just take it, I literally take a tube from a container of hydrochloric acid gas and I put it into a container of water and I open up a valve and I allow the HCl to bubble into the water, and the water dissolves it. Okay, so we got this part down, and so the rest of this problem is exactly like our last problem, right? 125 and 275. So 125 grams. One mole. And we have a mass for this?
It's 136.235.
That sounds good. And for every 1 mole, let's just make the carbon one. 10 moles C, 12.011 grams of C, 1 mole of C. And then we'll do the same exact question, 275 grams, except this time we'll go with Cl, 1 mole Cl2, and what is that, 35.465, all right, 465, no, 453. So 70.903 grams Cl2 and 8 moles Cl2, 10 moles carbon, and 12.011 grams of carbon, 1 mole carbon. Does anybody have any numbers for us, masses for carbons?
Yeah, that one's 110.
The first one?
Just 110.
The first one or the second one?
The first one.
The first one is 110 grams. Okay. Somebody have a number for the second one? Like 100 or something?
Yeah,
How much?
58.2.
Really?
yeah, that's what I got too.
Yeah.
Okay. All right, so which one's the limiting reagent? Chlorine is, right? I'm going to run out of the chlorine the moment I've made 58 grams of carbon. Okay, so then I'll do this one more time. 275 grams of Cl2, 1 mole Cl2, 70.903 grams Cl2, and 8 moles Cl2. And this time we're going to go to the 16 moles of HCl, 1 mole HCl, and 36.454 grams of HCl. Somebody have a number there? 70.
282.77. 283.
283? Okay, so what do we have 0 grams of in the container?
Chlorine gas.
There's no chlorine gas left over. So I've got some of my hydrocarbon, and I know I've got 50 58.2 grams of carbon, and I've got 283 grams of chlorine, or hydrochloric acid. And I started with how much stuff?
400.
400 grams of stuff. So how much of my hydrocarbons left over?
$58.8 grams.
58.8. Okay.